Hello, everybody. Last time we were talking about the solar system and the members of the solar system. And let's just review what we talked about last time, just before we move on and talk about what's beyond the solar system. So, to do that, just to jog your memory, why don't we put over here the sun, our star, the one star in the solar system. Why don't we put the major planets? Remember the closest planet to the sun? Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. This is showing just parts of the orbit. I should be showing them all the way around here, but I'm just going to shrink everything here. And so those are the 8 major planets. And remember, we also, I think that's 8 there. Should be, yeah, there should be 8. Maybe, yeah, did I put Pluto? Well, I don't know. But those are the 8 major planets. And remember, Pluto's been demoted. And the outer one would be Neptune. I'm just going to put Neptune, even if I put an extra one there. So let me see, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Yeah, that was Pluto. So remember, put a dividing line there. There's Pluto. Here would be Neptune. So Pluto is not, I'll just put a dividing line. Pluto is not a major planet anymore. Remember, it's a dwarf planet. So those are the major planets. Remember, we also had satellites going around major planets, even maybe minor planets. We had the minor planets, or the asteroids, a lot of them in the asteroid belt between Mars and Jupiter. We had the asteroid belt. We had comets, these dirty ice balls. So that's the solar system. So what I want you to imagine is this. I mean, the solar system is a pretty big place. It's pretty big. But really, compared to everything else, it's nothing. So let's imagine that the solar system, if the solar system is very, if it's very close to us, if we're in the solar system, which we are, it looks very big. But imagine something's getting farther away. Put your thumb close to your eye. All right? Very close. How does your thumb look? It looks big, very big. Now take your thumb, probably doesn't look good because it's very, maybe too close to focus on. Now take your thumb and move it farther away from your eye. How does your thumb look? Well, it's probably looking a little bit better, but it looks smaller. So if you get far enough away from the solar system, keep traveling far enough away, eventually there's really only one thing you're going to see. And the one thing you're going to see is going to be kind of yellowish white. Guess what that is? It's the sun. But really, if we get far enough away, everything is there. The major planets are there. That's the whole solar system. Now, I might put a kind of like where the Oort cloud would be, the comets, the outer part of the solar system. You wouldn't see these. But this is the solar system. This thing we're showing here is the solar system. It's our system, the system of the sun. You cannot see the planets because you're so far away from the solar system. We're imagining we're very far away. The only thing giving off its own visible light is the sun. And if the sun has been reduced to like a pinpoint, the planets are not going to show up at all. It's like trying to see a bug, a moth, going around a spotlight from a mile away. Maybe you might be able to see the spotlight from a mile. You should be able to see the spotlight, the light from a mile. But there's no way you're going to see a bug from a mile. Well, here we're talking about things that are way farther away than a mile. We're talking about millions and millions of miles, billions of miles, trillions of miles. You might be able to see the stars, the pinpoint, but you're not going to see anything going around it other than something giving off its own light. So the sun is the only thing giving off its own visible light in the solar system. Now, if this is the solar system, there's got to be other stars out there, and there are. Let's pretend we travel to the next closest star system. I'm going to put it on this page here. It should be farther than this. I should spread it out more. Well, the next closest star system, and I'll define that term shortly, is actually a triple star system. It's 3 stars. 3 stars going around each other. 2 stars going around each other here. Well, this star goes around those 2. This system is called the Alpha Centauri star system. Alpha Centauri, TSAU. This system has 3 stars. Alpha meaning the brightest star in the constellation of Centaurus. You can't see this even from Santa Rosa. You'd have to go farther south. It is a pretty bright star in the sky. It's really 3 stars. But we're not going to, the reason it's important, the reason that we want to say it's important right here, this is good to write down. I'm going to write it in green here. It is the closest star system to the solar system. I'm sure I'm going to ask you about that. Of all the stars you see at night from anywhere on the Earth, that's the closest system. And the reason we're not calling it a star is not just one star, it's 3 stars. It's a triple star system. So we might as well define what a star system is. A star system is a star and the bodies which orbit it. A star and the bodies which orbit it, which could be other stars, which could be planets, which could be stars and planets. Our star system is named the solar system. There's one solar system. The other star systems we see at night have their own names. We've named them. This one is called the Alpha Centauri star system and is the closest one to the solar system. Now, I want to show you a picture of this. Let's take a look at a PowerPoint for a minute here. So take a look at this image. In this image, you're going to see how you see a bunch of stars. And you also, this is a picture of the sky from somewhere in the southern hemisphere. Do you see these 3 stars right over here? And notice the colors. Look at some of these are blue. Well, that is kind of orangish. What does that mean? Temperature. Stars are all made of the same stuff, hydrogen and helium for the most part, trace other elements. The hotter stars are going to be bluer and white. The cooler stars are going to be reddish, maybe orange. Just like, think about a flame. When you see a flame, isn't the very center going to be blue? Like, think of a match. The very center is blue. It's the hottest part. What are the colors of the outer part? Isn't it kind of orangish red? Stars are not necessarily burning, but it's the same kind of principles. If you get, even like your burner at home, if you have an electric, or maybe your stove doesn't do this, but maybe a poker in the fire, or if you have a burner, an electric stove, you notice that the first color, it glows. I mean, when it's cooler, it's red, but then it gets kind of orangish. And if you can get hotter and hotter, it will eventually get white and then even blue. Your stove won't do that. But these stars here represent hotter stars, and these are hotter stars, and that's a cooler star. This is the Southern Cross, or crux. It's a cross. Look, there's the staff, there's the crossbar, but look over here. This star right over here is the star we put on a piece of paper. That is Alpha Centauri. Of all the stars you see at night, that one's the closest. And this constellation is Centaurus, so that means that Alpha just means the brightest star in that constellation. That's not even a star. I mean, it's 3 stars. It's 3 stars. It's not 1, 3. So we call it a star system. Look at this one. You know what that one is? Second brightest star in that constellation, Beta Centauri. And Beta Centauri is 100 times farther away than this system. This system, which is also 3 stars, is 100 times farther away than this. Can you tell that? No. You can't tell what stars are closer and farther. It's almost like as if there's all the same distance from you and some look brighter than fainter. But there are different reasons some are brighter than fainter. Well, here's one reason. Look at this. Look at the color of this. Kind of bluish. So the combined light from that star, those 3 stars there, is blue. The combined light from this one is actually kind of a yellowish. What does it tell you if this is blue, combined light? Doesn't mean hotter. Well, doesn't it? If it's hotter, it's going to be brighter. Some of these stars are at least hotter in here. Well, and also, if it's 100 times farther away than this grouping, wouldn't you expect it to be a lot fainter? That it's almost as bright as this means that there must be really, really bright stars in there. Hot blue stars. That's just one way you can tell that. All right, now, let's go back to our picture here. So, closest maybe have been sorry, it might have been a little bit out there. I couldn't see it at the time. So again, write down Alpha Centauri system is the closest star system to the solar system. That's important. So now, what we should do is this. What we're going to do is change scale. We're going to get far away from the solar system and the Alpha Centauri system, far, far away, and eventually it's going to look like this. Here is the solar system. Here is the Alpha Centauri star system. Looks like they're almost touching. Well, they're not really that close. We're going to talk about how far away they are from each other next time. Well, if they look like they're touching and they're really not that close, must mean that you are really far away. Look at these other star systems. Every time I make a speck, could be one star with planets. It could be a triple star system, double star system. Could have probably have planets. I mean, our star system does. So I'm going to try to make this kind of accurate, kind of like this. And it's even, I mean, we don't have enough time for this to do this correctly. I'm just going to kind of do this. This is kind of a mess. I don't know, hopefully you're taking notes. Everything I write down, I might test you on. So you should be taking notes on this. You should be doing this, because I could test you on this exact thing, what I'm doing. So take notes. And these are all star systems. Now, in order to finish what I'm doing here, and in order for you to finish, I'm doing about 3 star systems per second, 3 a second. To finish this and make it accurate at 3 a second, it would take 7,000 years. We don't have time for that, not today. Well, that's ridiculous. So what I'm going to do is trace out what this would have looked like, kind of like this. I mean, it's a terrible picture. You can also, I'll show you some images. Oh, boy. Kind of like this. It's kind of looking like this thing. And you might say, well, what the heck is that? Somebody will say, hey, it kind of looks like 2 sunny side up eggs back to back. Yeah, okay. It kind of looks like a wristwatch opened up. Yeah, all right. Some people say, oh, I have something for you. I have it right here. Some people have said it looks like the saucer section. Look at this. I don't know. Okay, can I do this? Look at this. Oh, boy. Look, I can't get it right. The camera's in the way. This is the saucer section. You know what this is? Look, you can see that. Of the Enterprise. But then some people have said, what's the Enterprise? And people have said, it's the ship from Star Trek. And people say, what's Star Trek? And the conversation's over. But today people know Star Trek, right? Because of the movies. People should know that. Well, all right. This is not the saucer section of the Enterprise. It's not eggs. It's not a wristwatch. What is this thing? It's a galaxy. It happens to be our galaxy, which is called this is good to know, the Milky Way galaxy. The Milky Way, or a lot of times abbreviated MWG. It is our galaxy. And this is like an edge-on view, kind of like, I don't know, can I do the saucer section of the Enterprise? Kind of like, look at that. You see that saucer section of the Enterprise? Kind of like this. That's an edge-on view. Well, then you can also have a face-on view. And a face-on view, let me get this back to where we were. And a face-on view would look different. A face-on view, you would have something like this. All right? So you kind of like a spiral structure. So but it looks different. Kind of a frisbee looks different from its edge, looking at its edge, as opposed to face on. Well, this is our galaxy. And again, a galaxy, we should define that. It is a grouping of billions of star systems. And what do you think keeps them together? Gravitationally bound. Gravitationally bound. So gravity's holding all these together. And in our galaxy, the Milky Way, they say there are 200 billion to 400 billion star systems. That's crazy. That's counting. If you want to know what that number is counting, it's 3. If you want to count 3 a second, it would take 7,000 years to count that. If you count 1 a second, 1, 2, 3, about 1, 2, 3, about 20,000 years. That's incredible. So there is our galaxy. And I'll talk about some things that we find in our galaxy, which are pretty interesting. And again, the solar system, it's probably, I think I'd put it right there. Really, the solar system is going to be somewhere like right there, something like that, about 2/3 of the way from the center to the edge. So the solar system, I'm just going to say it's right in the center of the circle, right over there. There's the solar system. The solar system, our system, solar system, right there. Now, when you go out and look at our galaxy, I'll show you some pictures of it. It does not look like this. It does not look like that. How does it look? If you've seen the Milky Way, our galaxy, we have trouble seeing it. You know why? Because we're in it. It's like being inside a pool and trying to see what the shape of the pool is. You really can't do that. It's like being in the ocean, trying to figure out the shape of the ocean. No, you can't do that. It's like being in the United States and trying to figure out the shape of the United States being in the U.S. You can't do that. You would have to get a view from way far outside of these things to see the shape of it. So what you see at night, this band of light, if you ever go out to a dark sky and have seen this all running across the sky, I mean, certain times of the year it's more apparent than others. What causes this band of light? Well, here's what causes it. Being inside our galaxy, here's what we can see. If we look out at night along the plane, if we look this way, we see so much stars and gas and dust, we can't, eventually we see very, very distant stars and can't see beyond it, too much dust. We look this way. It's very, very dense in stars. Look this way, even out of the paper, into the paper, very dense in stars. But if you look this way, look at this, and that way, aren't you not looking through as dense a region? It's like remember the pancake in Bruce Almighty at the end? I don't know if you remember that movie, but there was a big, actually it wasn't a pancake, it was a cookie. Yeah, there was a big cookie at the end. And it was like, I don't know, it's feet across. Imagine being in a big pancake or cookie, like your head in it, right? Like anywhere in it. If you look out along the flat part, if you're in it, all you see is cookie or pancake, a batter. That's all you see. But if you look up or down, away from the plane, 90 degrees to the plane, you're not seeing as much dough, not as much batter. So in our galaxy, if we look along the plane, the flat part, being inside of it, we're seeing a lot of stuff. And that's the band of light you see. If we're looking away from the plane, you don't see as much stuff. You're still seeing stars within our galaxy, but you're able to look out. It's like being in the ocean, or even in a pool, a few feet down, and and imagine people all around you being in this pool, and looking all around and like trying to see your friends, and you can't even find your friends. Just too many people in the way. A lot of people. If you look straight up, you're only looking maybe through a few feet of water. Couldn't you see maybe a jet plane 5 miles away? You can see because you're not looking through as much water and not looking through as much stuff. So being in the Milky Way, you don't see it that well because we're inside of it and we're looking along its plane. So we really can't see that much within our galaxy because we're in it. We're kind of stuck in it. There's too much dust in the way. We can't see that far. So now, let me show you some pictures. Let me go back to our PowerPoint. And we'll share again. And let's see some things that we're going to talk about in our class besides stars. We have places like the Orion Nebula where stars are being born. It's a cloud of hydrogen gas. Hydrogen, when it's heated up a little bit, excited, it glows reddish. And that stars are made of hydrogen. These clouds are enormous in size. And you see why it's bright in here? It's bright because baby stars that were born within this cloud from the hydrogen have heated up the cloud around it, caused it to glow red. It's called an emission nebula. We'll talk a lot about these. Orion Nebula is one of the most famous ones. I mean, I think it probably is the most famous one. Just beautiful. The colors you see here are real colors. When you take pictures, you get real colors. When you're looking with your eyes, you can't. But kind of like this, at full moonlight, you can go out at night and see the ground, but you certainly can't see much color with full moonlight. Everything kind of looks kind of grayish. But if you were to take a picture in full moonlight and let your camera expose for maybe even 10, 20 seconds, you'd start seeing color. Our eyes cannot pick up the color in the sky like cameras can. Your eyes are not able to take in as much light, our eyes just cannot do it. So look, here's the Orion Nebula, close up. We'll talk about this. Just beautiful. Here's a place where a star died. It's called a planetary nebula. So we'll talk about that. A star like the sun died, and it gave off its outer shells. Here's a place where a star is very massive, blew up. It's called a supernova remnant. This one happens to be called the Crab Nebula. We'll talk about that. Well, look, here's our galaxy as seen from inside. There's the plane of our galaxy, this reddish area, emission nebulae, hydrogen. So everything in this picture, and there's the Milky Way, the plane, our galaxy is seen from inside. It's all part of our galaxy. But look at this. See that? That's another galaxy. If we can look outside our galaxy, we find other galaxies. Look at this. Here's a picture that one of our assistants, John Bloomer, he's a great photographer. If you ever are able to take Astronomy 12 and we're able to get outside and use telescopes and cameras, you get shots like this. Just a beautiful view of the Milky Way with some clouds. There's the star Antares and Scorpius the Scorpion. There's the Stinger the Scorpion. Sagittarius is right over here. Look, you see, there's dust lanes here. The reason we can't see it all the way to the center, a lot of dust, but that brightness here, those are stars at great distances. We're looking towards the center of the galaxy. Can't see all the way there. That's a great shot. Look at this one. I think John took this one too. A Milky Way boat, because he used a wide-angle lens, a fisheye lens, with the brightness from Santa Rosa and Windsor and even Hillsburg in the background from Lake Sonoma. Just a great shot. Look at this view. No, John didn't take this one. This is kind of an enhanced picture. Still from inside our galaxy. We can't see the way our galaxy looks from outside of it. We can't get outside our galaxy. But look at the dust lane. All that black is dust. Carbon and iron dust. Look at another galaxy right here. And, oh, don't want to show you that yet. All right, go back. Back. I can't go back. All right. I'm just going to oh, boy. It's not letting me. All right. I'll just have to stop share here. So let's go back to this. Let's talk about other galaxies here. Let's go back to this picture. Let's go back to this picture. It turns out the closest galaxy to us is colliding with us. There's a little galaxy that's right over here. It's in the same direction as the stars we call Canis Major. So what we have called this galaxy is the Canis Major, C-A-N-I-S, for the big dog, Canis, like canine, Canis Major Dwarf. That is important because I'm going to write it down here. I'm going to write it in green. It is the closest galaxy to the Milky Way galaxy. That's a good one to know. I'm going to put a star right there. Closest galaxy to the Milky Way galaxy. So just like Alpha Centauri star system was the closest star system to us, the closest galaxy to the whole Milky Way, and the Milky Way is enormous, is the Canis Major Dwarf. Before we knew about this galaxy, we used to think this one over here, another little galaxy. Most galaxies are very small. Here, it's a little galaxy. This one called the Sagittarius Dwarf. Sagittarius Dwarf galaxy. S-A-G-I-T-T-A-R-I-U-S, Sagittarius, S-A-G-I-T-T-A-R-I-U-S, dwarf galaxy. They thought this one was the closest. Well, until they found this one. They're hard to see. I mean, they're hard to see, especially looking through the plane of our galaxy. They didn't really originally call this the Sagittarius Dwarf right over here. You know what they call? I shouldn't even tell you. This is going to be recorded. I'll tell you anyway. I don't know. I have tenure. They really can't fire me unless I commit a felony, like on campus. And I don't plan on doing that on campus. They called the Sagittarius Dwarf, this little galaxy they used to call Snickers. You know why? I still shouldn't be telling you this. Because it was peanuts compared to the Milky Way. All right, I'm glad I don't hear your boos right now. That's kind of nice. But they don't call it Snickers anymore. I think it was just in fun. They were calling it Snickers. It's the Sagittarius Dwarf galaxy. Now, on the scale also, I'm going to kind of tuck them in here. Actually, right over here, just to save some paper. Here's one and here's one, kind of on the scale. I forget the words here. There are two galaxies here that the sailor, the Portuguese navigator, he saw them. I mean, people saw them before that. They're naked eye. These are naked eye. You can see them. Well, Magellan said these things look like clouds in the sky. He logged them. He said, these clouds that he's seeing. But he realized he kept seeing them every night. And if he saw them every night, they must not be clouds in the atmosphere. They must be farther away because he wouldn't have the same clouds every night, looking at the same spot. Well, we know what they are today. They are galaxies. But because Magellan actually logged them, we actually have special names for them. They're called the large and small Magellanic clouds. Large and small Magellanic clouds. There they are. In other words, here's the LMC, the Large Magellanic Cloud, and the SMC. So we'll talk about the distance of those. So take a look at that. Now, look at all this. Let's change scale. See how big the Milky Way is? Actually, just tell you how big the Milky Way is. If the solar system is the size of a dime, let's say we shrink everything in the solar system to the size of a dime, which is nothing, the whole Milky Way galaxy would be the size of the United States. How big is a dime compared to the United States? There's really no comparison. So an individual star system in a galaxy is nothing. Even though if anybody happened to have it, that star system, like us in the solar system, it seems pretty big. Like the solar system seems pretty big for us, but compared to a galaxy, it's nothing. Well, now, knowing that, take a look at the Milky Way. No, terrible picture. Sorry, I can't erase with this. Usually with a board I could erase. You're not, if you can't tell what that is, it's the Milky Way galaxy. Milky Way galaxy. Remember the Canis Major dwarf? Right here. Remember the Sagittarius dwarf there? Remember the clouds of Magellan right here? So we're far away to see it's like this. These things are enormous, but we're seeing it very, very small because we're imagining it's far away. Well, here's a galaxy you might know about. If we go back to this picture, if we look beyond the stars that make up Andromeda this way, and that's how galaxies get their name. Think about this. Remember we look past the stars that make up Canis Major, so we name this galaxy the Canis Major dwarf. We actually look past stars that make up Sagittarius, constellation of Sagittarius, the Archer. We detect this galaxy, so we call it a Sagittarius dwarf, dwarf meaning small. Well, we look past the stars that make up Andromeda this way, and we find a galaxy maybe twice the size of ours, also a spiral, kind of a spiral-looking galaxy. You know what it's called, if we're looking past the stars that make up Andromeda? The Andromeda Galaxy. Andromeda Galaxy. It is we'll talk about this, the distance. It is the farthest thing you could see with your naked eye. It is the farthest thing you see. It's a galaxy. You can look out and you can see the smudge in the sky. And it is a galaxy. It is probably about maybe 400 to 500 billion star systems. And it looks like a smudge to your eye because it's so far away. So I'll show you a picture of that shortly. But I want to show you some other galaxies. Here's a little one. That's a little spiral. We're kind of a smaller spiral. Most of them are these dwarf galaxies that we're, different. These are very, very small. And it turns out there are about over 50 of these that we've discovered. 50 galaxies. And you know what they're doing? Well, they're going around each other. I'm going to circle this. They're kind of like in this region. Here they are. There are these galaxies here. Now, when I make a spectrum, it's not a star system. It's billions of star systems. So this is crazy. You really can't get scale here. You can't visualize this. No one can. Don't worry about it. Humans cannot do it. Now, if you ever see the movie Lucy, I'll give you an extra point if you see Lucy. It's Luc Besson, one of my favorite directors who directed Leon, the Professional, one of my favorite movies of all time. Directed Lucy, kind of a violent movie, but it's with Scarlett Johansson and Morgan Freeman, and I know they're great. And it's a science fiction movie about a woman who ingests a drug accidentally, and she starts using more and more of her brain, and is eventually able to become this very powerful. I'm kind of ruining it for you. Very, very powerful. I'll keep it short. She becomes very, very powerful, being able to use a lot of her brain and visualizing things. If we were able to use more of our brain, maybe we could visualize something like this and how big things are and the distances. But we can't. We're human. We can't do it. So a lot of these things in this class, you're just going to have to think, big distance. I really can't visualize it, but it's big, or this object's big. You're not going to get to visualize it unless you're like Lucy. So I'll give you a point, extra point just for seeing Lucy. All you have to do is tell Joe, your assistant, you saw it. If it's a one-point movie, you just see it. It's the honor system. You see it, you get your point. You don't have to write up anything. If you want more extra credit, where you actually get maybe a little bit more points, look at the syllabus. At the syllabus, it tells you what you can do for extra credit. But for the one-point movies, just watch it. Oh, and you might as well watch Leon. Leon is not even a science fiction, but it's Jean Reno, Natalie Portman. I think one of Natalie Portman's first movies. It's a great movie. Well done. So it's kind of violent, though. If you don't like violence, don't see it. But I get a point for that. It's one of my favorite movies. I got to give you a point for it. All right. But again, if you don't like it, just don't watch it. Get points other ways. All right. So now, this is a cluster of galaxies. A cluster. Because these galaxies are going around each other. They're orbiting around each other. And we have called our cluster something. This is our cluster because we're in it. It is called the local group. That's good to know. I'll circle with green. It's not part of this. I'm just circling that. It is our cluster of approximately 50 plus galaxies. Approximately 50 plus. That's kind of a strange way to say it. You don't have to know that number. About 50 galaxies. The local group. Now, let me show you some of the things. Let's go back to this. Let's go back and I'll show you some of the things we're talking about. Now, I don't even like these two things. I'll show it to you anyway. But let me go back to this. And this kind of shows, this is not even a real picture. It shows our galaxy shown in blue, the Milky Way, and it shows in red what we're doing. Gravitationally to the Canis Major Dwarf Galaxy, we're tearing it apart. At some point, it's just going to be absorbed into our galaxy. And it's kind of weird. When galaxies collide or hit, stars don't even hit. The stars don't even hit. They're so far apart in a galaxy. So galaxies can take billions of years to move through one another. The stars, for the most part, will not even collide. So a galaxy, though, can get torn apart by another galaxy, by a more massive galaxy, due to something called tidal forces. We'll talk about that. Well, look at this. Here shows this is a terrible picture. It's not even a picture. It shows our galaxy, and there's a Sagittarius dwarf on the other side, and where the sun is, another star in there, Sirius, Betelgeuse. Let's move on here. Here's the Large Magellanic Cloud, one of our nearby galaxies that we saw on the sheet there. It's an irregular galaxy, no distinct shape. Here's the Andromeda Galaxy. Look at that, just beautiful. When you take a picture, you can see the spiral structure. I mean, there's the center of the nucleus. It has companion galaxies going around it too. So it's Andromeda Galaxy, just beautiful when we take a picture. In Astronomy 12, if you took a normal Astronomy 12, where we get to go out, a lot of times of the year, we get a picture of this, of the Andromeda Galaxy, and it's almost as good. This is not our picture, but we have digital cameras where we can, hook them up to a telescope and get good shots. Well, now, let's go back and talk about a little bit more. We have a little bit more to go. Almost finished right here. But there's some important things we have to talk about, and that's it. Look at this. Here is the local group. Let me show it to you again. See this, everything in green here? I'm going to show it again. Here's the local group. Wait a second, what happened to it? Well, you know what happened to it? Look at that, all 50 galaxies here. I can't even show them here. I can show, maybe I can show the Andromeda, and too big. Milky Way, too big. I can't show the other. 50 galaxies in here. What we did is we went farther away. That's the local group. If you're not sure what that is, I'll put LG for local group. That's our cluster of galaxies. Now look at this. Now I should make these three-dimensional. I'm not. I can't draw that now. If that's our cluster, guess what these are? Other clusters of galaxies. Other clusters. And what I'm going to do, I can't really do this very well, but here's what they're saying. These are clusters. Here is a cluster of clusters. There should be 300 here. Maybe up to 300. I'm not going to do that. I'm just going to circle it, kind of like this. And imagine about 300 or so clusters of galaxies that are clustered together. Clusters go around clusters. And if you have a cluster of clusters, you know what you have? A supercluster. A supercluster is a cluster of clusters of galaxies. And we have a name of ours. Well, you know, the old name of ours, which is not so good, number one, was called the local supercluster. That's ours. This whole thing. I mean, there are about up to 300 clusters in here. There's a better name. Over the last 5 years or so, we finally have a good name, a Hawaiian name, Laniakea. Laniakea means immeasurable heaven. It's another name for our supercluster. I'd like you to know it, Laniakea. If it has a good name, you might as well know it by the good name. At some point, I might mention the local supercluster, but it's the same thing. It's the name of our supercluster. Now, look at this. Is this it? Is this everything? No. You see, this is amazing. I mean, you can't even barely see the Milky Way in this. But watch this. You see this whole thing? Our local supercluster, Laniakea? Let me show you again. There it is. If you're not sure what that is, write it down. Laniakea. That's our supercluster. In here, there are 300 clusters or so. And ours, one of those is a local group, which has 50 galaxies, and ours is one of them. Well, look at this. If that's our supercluster, guess what this is? And really, it's another supercluster. And another. Really, there should be like web-like, the way galaxies and clusters and superclusters are structured. I'll show you a video of that. Really, it's crazy. I mean, I cannot do this justice. I'm showing superclusters here, and superclusters actually spreading apart from one another. Everything's expanding. I mean, as far as space. We'll get into that. Now, I'm not going to show all the superclusters because what I showed just the local supercluster, how many groups are clusters in here? I said about 300. I could almost do it. I probably did about 30 of them. Well, you know how many superclusters I'd have to make this accurate and extend out? I'd have to make, I think now, they're saying, here's what they're saying. There's 1 million plus superclusters. I think they're even, 1 million plus. I think I heard something like saying that there could even be like 100 million superclusters. It's crazy. You don't have to know it. 1 million plus superclusters out to as far as we can see, and all these superclusters are moving apart from one another for some reason. We're going to talk about that. And with all these superclusters, everything, all the superclusters which contain all the galaxies, what do we call everything? We call everything the universe. Universe. Just write everything. Everything we know. There might even be more universes. We might live in something called the multiverse, where there are other universes we can't even get to because they're in different dimensions. So that's everything. The universe, all of space, all of time, all galaxies in the space in between, however you want to say it, you just want to write down everything that's good enough. So that's the universe. And in the universe, I'm going to write this down. There are 100 billion plus galaxies. 100 billion plus galaxies in the universe. Let me show you some of them. It's crazy. What they're saying now is that this should be even like maybe 100 times. 100 billion could be trillions. It's just ridiculous. Let me show you a few things here. Let me share with you a few more pictures. And so remember, Andromeda Galaxy. The Whirlpool Galaxy. This is still really relatively close to us. It's in the local supercluster in Laniakea. Just beautiful. Look at the spiral arms, star-forming regions where you see those reddish colors, the emission nebula, where stars are forming in those areas. You see these dust lanes in there. Just beautiful. The blue you're seeing in here, the blue are very hot, massive stars. And those are rare. So if you're seeing those stars, there's tons more of lower mass stars you can't see. There's another picture of the Whirlpool Galaxy. With a companion? There's a companion. The Sombrero Galaxy, not the best picture of it. They say there are about 1 trillion star systems in this one. Sombrero Galaxy. There's another view of the Sombrero with different filters. You see it looking at a different light where you see the dust lane much better, the Sombrero Galaxy. Well, look at this. If you see the movie Galaxy Quest, well, at the end of the movie, actually, that's an extra point just for watching it. Galaxy Quest. Really funny science fiction movie. It's a good laugh. It's a Galaxy Quest. This is called the antenna. 2 galaxies colliding. So look at that. Just beautiful galaxies there. We get images of galaxies colliding. Again, it takes them billions of years to collide, so we don't see the whole thing from beginning to end. We're just getting glimpses of it. The Tadpole Galaxy. Look at that. And in the background, you know what most of these things are? Other galaxies. Look at that. Looks like a star in our galaxy. There's a star in our galaxy. If you see these spikes on them, looks like a little spikes. That means it's a pinpoint, and the telescope that took it has these bars in it, and the light bends around the bars. So if you see something with spikes, it's artificial. Just means the instrument that took it has these bars. But look, these galaxies in the background. Look at this. Now, got to talk about this. This is called the Hubble. I think it's just the deep field. It might be the ultra deep field. This is a view, except for maybe a few stars in here, 1, 2 in our galaxy. Everything beyond, every little speck you see, it's usually hundreds of billions of galaxies. Look at that. See that star in our galaxy? There's a star in our galaxy, the Milky Way. See a little speck right there? That's 100 billion of those. You say, no, it's not. And this is way more impressive than this. No, it's not. That's close, relatively. And these other things are far. So we're seeing these galaxies in the distance. In this view, there are 10,000 of them. 10,000 galaxies! But that's not what's impressive. That's impressive. It's not what's most impressive. The field of view of this, what's the size of the sky that's blocked off here to see this? If you hold a pin at arm's length, close one eye, and look what the pinhead is blocking, it's this. You're saying, whoa, that's impossible. That's why we're estimating this 100 billion galaxies or more in the universe. We're not counting them. We're just seeing how many are in a very small region of the sky in a very distance. And then we're seeing how, extrapolating to everything else. So that's incredible. Every speck you see, except for maybe 6 stars in here, is a galaxy containing hundreds of billions of star systems. And this is what's blocked by a pin at arm's length. Now, if there are that many galaxies in the universe, how many stars do you think there are? Aren't there more? The data should prove. Now, I mean, aren't there more stars than galaxies? Well, you know how many stars there are in the whole universe? If you imagine all the grains of sand and all the beaches of the whole world, you can't even imagine that, so sorry to even ask you. But if you can try to even think about it, you say, no, I can't do that. I can't imagine all the grains of sand. Well, you know, it's ridiculous to imagine because there's so many. At least you know that. Well, if you imagine all the grains of sand, even if you pick up a handful of sand, you can't even imagine how many grains of sand are there. It could be millions, hundreds of thousands. Well, imagine all the handfuls of sand on all the beaches of the whole world and multiply that by 3 million. That's how many stars there are. And the sun is one of those stars. So you tell me, are we the only ones in the universe? I mean, I refuse to believe that. If that is the universe, that would be incredible. It's the most incredible thing if we're the only life form. If that many stars, think about there are even more planets. We're even discovering planets kind of like Earth out there. Far away, still in our galaxy, but still far. So there must be life out there everywhere. Now, I'm not the kind of person that believes that the government's hiding aliens. I don't see good evidence for that, or we've been visited by aliens. A lot of people. I mean, you watch like Ancient Aliens and things like that. I try to stay away from that. That's not scientific. I mean, really. I mean, it's interesting, but no, we don't have good evidence of aliens coming here. But that doesn't mean they're not out there. I think if the universe is not, if we're the only people in the universe, if we're the ambassadors, that's a sad universe. That's embarrassing if we're the only ones. I don't want to be embarrassed. I mean, I've been embarrassed enough over the past, week or so, 2 weeks of stuff going on. I mean, it's ridiculous. I've been embarrassed for years now. But yeah, if we're the only life in the whole universe, that universe it needs to really seriously think about itself. I think there's life all around, but still so far away we can't get to it. But there are scientists that think we're going to be contacted an intelligible signal, maybe within the next 30, 40 years, that we might get a signal from Contact. You got to see the movie Contact. Maybe the most accurate science fiction movie of all time where something could happen. I'm going to show you a little bit of it even next time. So these are things to think about. Again, if you don't like what I'm saying, I'm sorry. I mean, you don't have to agree with me. I'm just telling you what we think to be the truth is. But just telling you what I feel sometimes. Again, you don't have to go on my viewpoint. You can have your own viewpoint. That's perfectly fine. But I'm telling you, I've been looking at this stuff for years, and I'm trying to tell you what we think is really happening out there, and it's just amazing. So that's it for now, and we will talk next time about distances. And so stay tuned, and we will end this meeting. So take care.